Good morning students. In this video we will see some more types of integration, special types. They are known as integration of rational trigonometric functions. Integration of rational trigonometric functions. There are four types. We will discuss one by one. So all the four types, they are very important. They can be expected in long answer question in the final exams. So let us see integration of rational trigonometric functions. In this there are four types. Type 1 is, what is type 1? For the integrals of the type 1 divided by a plus b cos square x into dx. Rational trigonometric functions. Rational trigonometric functions means fractions involving trigonometric functions. This is first one. Next, integral 1 divided by a plus b sin square x into dx, or integral 1 divided by a cos square x plus b sin square x into dx. And also one more, integral 1 divided by a cos square x plus b cos x into sin x plus c sin square x into dx. These four come in first type. What are those? Integrals of the type 1 by a plus b cos square x. Second one, integral 1 by a plus b sin square x. Third one, integral 1 by a cos square x plus b sin square x. And fourth one, this is fourth one, 1 divided by a cos square x plus b sin x cos x, or cos x sin x plus c sin square x. These are the first type of integrals, rational trigonometric functions. So how to integrate these functions? You please observe all the four, they contain cos square, sin square, or both, and also without powers a term containing cos x sin x. So for these four there is a procedure. What is the procedure for integrating these? Very simple. What to do? Multiplying numerator and denominator. This is procedure, Nana. Multiplying numerator and denominator by secant square x. By secant square x, multiplying numerator and denominator by secant square x. That means dividing numerator denominator by cos square x. Both are same. So multiplying numerator and denominator by secant square x, and then taking the substitution. What substitution? Tan x is equal to t. That's all. So for this First type of, this is type 1 in integration of rational trigonometric functions. These are the 4 in the first type. All the 4 are in terms of cos square and sin square, or 1 cos and 1 sin. Totally there should be 2 trigonometric ratios. Okay. For these 4, for this type 1, what is the procedure? Multiplying numerator and denominator by secant square x. Multiplying numerator and denominator by secant square x. Then taking the substitution tan x equal to t. By multiplying numerator and denominator by secant square x, then taking the substitution tan x equal to t, automatically those integrands become they get standard integrand. So by taking this, by approaching this procedure, they become standard integrands. You can differentiate. Already we have a list of formulae. Okay. Now we will see a problem on this type 1. After completing that, we will go to type 2. There are 4 types. Yes. See this problem. Integral 1 divided by 2 sin square x plus 3 cos square x into dx. This is integration of rational trigonometric functions in which first type. So what is the procedure? Very simple. Procedure: multiplying numerator and denominator by secant square x. Multiplying with secant square x means dividing by cos square x. So if you multiply denominator by secant square x, that means dividing by cos square x. We get 2 tan square x plus 3 cos square x by cos square x is 3 into dx. So I have multiplied numerator and denominator by secant square x. Then what should be taken? Procedure is, then take tan x is equal to t. If tan x equal to t, then differentiating secant square x dx will be dt. I have taken this substitution. Integral of secant square x dx. Secant square x dx is what? Dt. Divided by, we have taken tan x equal to t, no? Therefore t square plus 3. I will arrange this as dt or 1 divided by, here 2t square is there, no? I can write root 2 into t whole square plus 3 is there, which can be root 3 whole square into dt. See, by adopting this procedure, multiplying numerator and denominator by secant square x, then by taking the substitution tan x equal to t, the given integral becomes a standard integrand. It is of which type? See Nana, it is of the type 1 divided by x square plus a square into dx. Just variable is different, that's all, everything is same. For this, what is the integral? Its integral is 1 by a into tan inverse of x by a plus c. This is the integral. We will apply this. Variable there, variable is x, here is t. A variable can be any letter, no problem. It is integral 1 divided by x square plus a square. See, this should be linear. Only t term is there, therefore it is linear. You can apply that, no problem. Therefore, what is the integral 1 by a? 1 by a means 1 by root 3. into tan inverse of x by a. What is x? Root 2t by a is root 3 plus c. So I have applied this, but in place of x, what is there? Linear is there. Linear means power 1. T, only t is there inside the bracket. That is in place of x, we will have root t. T is first degree, linear. Okay, that formula can be applied. But what is the derivative of root 2t to root 2t? Its derivative is root 2. So you have to divide this by root 2. That is, write the derivative in the denominator. In differentiation, we will be writing derivative in the numerator. Therefore, what is this finally? So 1 by root 3 into root 2 is root 6 into tan inverse of. T is not given in the question. Therefore, replacing t by tan x divided by root 3 plus c. This is the answer. Yes. We will see one more example for the type 1. Another integral 1 by 4 sine square x 3 sine x cos x plus 2 cos square x. Rational trigonometric functions of type 1. What is the procedure? I said multiplying numerator and denominator by secant square x. Multiplying with secant square x means dividing by cos square x. Therefore, sine square by cos square is tan square x. Here, if you divide by cos square, one cos will be cancelled. Sine by cos will be tan x. And here, dividing by cos square, you will get 2 into dx. After dividing with this or multiplying with secant square theta, what is the procedure? You should take tan x equal to t. Differentiating this secant square x dx will be dt. Yes. Therefore, now this becomes integral of secant square x and dx. It becomes dt. What will be there in the denominator? We took tan x equal to t, no? 4t square plus 3t plus 2. Now we will express this in terms of a square plus x square or x square plus a square in that form. See now, I am taking this 4t square plus 3t plus 2. This is also a model we have seen in the fourth video I think. So firstly I will take 4 common here. If I take 4 common, I have t square plus 3 by 4 into t. 2 by 4 is 1 by 2. Yes. Now I will try to express this in perfect square. What is this? T square. We need 2ab. There is no 2 in the numerator. Therefore, I multiply and divide by 2. 2 into I wrote t. I have to divide, no? Therefore, this becomes 3 by 4 by 2. That means 3 by 8. Now it is exactly a square plus 2ab. Plus, if b square is there, it can be written as perfect square. Therefore, adding and subtracting this. Also, we have 1 by 2 here. Therefore, this 4 is for entire expression. First 3 terms, they become t plus 3 by 8 whole square. Then we have those two, no? If I take LCM is 64. I get minus 9 plus 32. Minus 9 plus 32 is plus 23. divided by 64. Yes. Now by taking this integral becomes 1 divided by, in place of this I can substitute this. 4 is constant, I will write outside. What is there here? It is t plus 3 by 8 whole square plus 23 by 64, that can be written as root 23 by 8 whole square into dx. See, it is a standard integrand. Again, it is which standard integrand? Integral 1 by x square plus a square into dx, whose integral is 1 by a into tan inverse of x by a, of course, plus c. So in place of x, what we have? Linear we can apply, no problem. See, 1 by 4 into, if I apply that 1 by a, this is a, 1 by a means it's reciprocal. 8 divided by root 23 into tan inverse of x by a. What is x? T plus 3 by 8. By a is root 23 by 8 plus c. Let us simplify this. 4 gets cancelled 2 times. 2 divided by root over 23, and we have tan inverse of, if I take LCM, I will be getting 8t. What is t? T is tan x plus 3 will be there. This LCM and 8 in the denominator gets cancelled. This is the integral of the given integrand. Yes, this was type 1 in rational trigonometric functions. Now we will see type 2 of this. Right. What is type 2? Type 2 is for this. Integral 1 divided by a plus b cos x, no powers, into dx, or integral 1 divided by a plus b sin x into dx, or integral 1 divided by a cos x plus b sin x plus c into dx. For these type of rational trigonometric functions, what is the substitution? What is the procedure? Listen carefully. For these 3 types of integrals, what is the difference between type 1 and this? In type 1, squares were there. Here no squares, only sine and cos. Here the procedure is to take directly taking tan x by 2 equal to t. This is the procedure substitution here. For these type of integrals, what is the procedure? Take the substitution tan x by 2 equal to t. What is substitution method? It is also known as change of variable. Now you have to change entire integrals into the variable t. How to change? Here dx is there, here cos x is there. See, we have taken this as t, no? If I differentiate this, tan derivative is secant square, and 1 by 2 derivative, x by 2 derivative is this, into dx is equal to dt. So this implies dx is equal to, If you write 2 on other side, it will multiply. Secant square x will divide. Secant square x is what? 1 plus tan square. Therefore, I can write 1 plus tan square x by 2. Therefore, this is 2 dt divided by 1 plus t square. By taking the substitution, tan x by 2 equal to t. Taking substitution means change of variable. So this will be the value of dx in terms of t. Similarly, if cos is there, cos can be changed to t. We know tan x by 2 equal to t. We have a formula. Cos x is equal to 1 minus tan square x by 2 divided by 1 plus tan square x by 2. We have seen in trigonometry. Therefore, this cos x is 1 minus tan x by 2. Here it is t, no? Therefore, 1 minus t square by 1 plus t square. This is the value of cos x in terms of t. Also, sine will be there. For sine, what to do? We know tan x by 2, no? Using sine 2a, it is 2 tan x by 2 divided by 1 plus tan square x by 2. So therefore, here sin x becomes 2 into tan x by 2 is t, and this becomes 1 plus t square. So this is the value of sin x in terms of t. Yes. What is this? Integration of rational trigonometric functions. Type 2, second type. If the given integrals are of this form, which are in terms of sine and cos, both are any one. This is the substitution. What is the substitution? Tan x by 2 equal to t. Substitution means change of variables. So cos x is to be changed, no, dx has to be changed. By taking this substitution, this will be dx and this will be cos x. And what about this? This is sin x in terms of t. You can remember them directly. What is dx? 2 dt by 1 plus t square. What is cos x? 1 minus t square by 1 plus t square. What is sin x? 2t by 1 plus t square. Yes, we will discuss one example on this type 2. Here is the question. Integral 1 divided by 3 plus 2 sin x. In type 2 there are 3. For all the 3, same procedure. I will do this. So what is the substitution for this? Substitution is tan x by 2 equal to t. So I am not differentiating. Directly I am writing dx. What is dx? 2 dt by 1 plus t square. Also there is a sin, no? Sin x will be 2t divided by 1 plus t square. If cos is there, what will be the cos? 1 minus t square by 1 plus t square. Okay. So therefore this integral is equal to 1 divided by 3 plus 2 into sin x. What is sin x? 2t divided by 1 plus t square into dx. What is dx? 2 dt by 1 plus t square. Change of variable has done. So integral 1 divided by, no problem, 1 into 2, I can write 2 here. If I take LCM, this will be 3 plus 3t square plus 4t This LCM 1 by t square, this 1 by t square gets cancelled. See, now I will take this which is there in the denominator. What is there? 3t square plus 4t plus 3. I will transform this into the form x square plus a square, or x square minus a square, or a square minus x square. Which one is possible? We will get that. So firstly I will take 3 common. If I take 3 common, this will be t square plus 4 by 3 into t plus 1. We will try to write in perfect square. What is there? T square, that means a square. 2ab is required. There is 2 here. Therefore 2 into t into what will be there? Only 2 by 3 will be there because we wrote 2 here. Now this is a square plus 2ab. If b square is there, it can be written as perfect square. Therefore adding and subtracting 4 by 9. Therefore this is 3 into first 3 terms, a square plus 2ab plus b square, which is a plus b whole square, t plus 2 by 3 whole square, minus 4 by 9 is there plus 1. If I take LCM, minus 4 plus 9 by 9, which is 5 by 9. Yes. Now I will write here it is. Here 2 is constant, can be written outside. We have 1 divided by in its place. This is what? 3t square plus 4t plus 3 can be written as this. Here also 3 constant. It is in the denominator. I wrote outside. What is there now? T plus 2 by 3 whole square plus 5 by 9 is root 5 by 3 whole square into dx. Yes. Again it takes standard integrand form. Integral 1 by x square plus a square into dx. It can be anything, x square plus a square. Sometimes you get x square minus a square. Which form you get? You use that formula. List is there. For what is this? It is 1 by a into tan inverse of x by a plus c. We will apply here. Therefore this is what? 2 by 3 into 1 by, this is x square plus a square. In place of x we have this which is linear, can be applied. So 1 by a, this is a. 1 by a means reciprocal of this into tan inverse of x by a. What is x? T plus 2 by 3. A is root 5 by 3 plus c. We have applied this. In place of x we have a linear factor. When linear factor is there, this can be applied, but you are supposed to divide with its derivative. What is derivative of t plus 2 by 3 with respect to t? T derivative is 1, 2 by 3 derivative is 0. 1 plus 0 means 1 only. You are supposed to divide by 1. Dividing by 1 means nothing, no problem. So here 3 gets cancelled. Therefore this is 2 by root 5 into tan inverse of. If I take LCM, this is what? 3t. I have to replace t. T is what? Tan x by 2 plus 2. This LCM which we have taken in the numerator, that 3 and this 3 will be cancelled. We will have by root 5 only plus c. This is the answer. We will see one more example on this type 2. See, integral 1 by 5 plus 4 cos 2x. Only cos is there. If power is there, it comes in type 1. But you please observe, here 2x is there. When I said type 2, there it was only x. In that case, I said to take the substitution tan x by 2 equal to t. When cos x is there, what is the substitution? Tan x by 2 equal to t. But here 2x is there, no, therefore our substitution will change. Now I have to take tan x equal to t. If only cos x or sin x is there, substitution is tan x by 2, half of this one. So now here 2x is there, this will be the substitution. Now differentiating this, secant square x dx is equal to dt. So dx is equal to, what is this? dt by secant square. Secant square is 1 plus tan square. You can write 1 plus t square. Also I need cos 2x, no? Cos 2x is 1 minus tan square x by 1 plus tan square x. That is, cos 2x in terms of t is 1 minus t square by 1 plus t square. This remains the same, but here it will be changing. When x cos 2x is there, cos x is there. So therefore this becomes integral 1 divided by 5 plus 4 into, what is cos 2x? 1 minus t square by 1 plus t square. Yes, into what is dx? Now it is only dt by 1 plus t square. Yes, this implies 1 divided by, I shall take LCM here, then I will get 5 plus 5t square. Here 4 minus 4t square. This LCM 1 by t square, this 1 by t square gets cancelled. Therefore, now this is integral 1 divided by 5t square minus 4t square is t square. 5 plus 4, 9. 9 means 3 square into dt. What is this? Again standard integrand. Integral 1 by x square plus a square. For this, what is answer? 1 by a into tan inverse of x by a. Here x is t and a is 3 plus c. Therefore finally 1 by 3 into tan inverse of, in this problem what is t? T is tan x, not tan x by 2. Here it is tan x only, plus c. This is the answer. So in type 2 there are 3, no? In terms of only cos, sin and cos. For all the 3, same procedure. In your textbook these models will be there. You please do practice. In this rational trigonometric equation we will see next type. Type 3. Yes, type 3 is for this type of integral. Integral a cos x plus b sin x, most important 3 and 4, divided by c cos x plus d sin x into dx. Yes, for this type of integral, how to find its integral, what is the procedure? See carefully. So here the procedure is, see carefully now. You take the numerator a cos x plus b sin x, numerator equal to some constant a into denominator. c cos x plus d sin x plus some other constant b into d by dx of denominator. What is denominator? C cos x plus d sin x. Yes, this is the procedure for this particular model. Yes, what I wrote actually, see now. A cos x plus b sin x means numerator. I am once again writing. Numerator should be expressed as a into denominator. What is this? This is denominator plus b into d by dx of denominator. This is the procedure. If you adopt this procedure, automatically the given integral will come into standard integrand. Easily you can integrate this. So this is the procedure. What is this? Numerator equal to a into denominator plus b into d by dx of denominator. Both are same. Yes, this is the procedure for this. For which type 3? Numerator contains cos term, sin term. Denominator contains cos term, sin term. For this type of, these are long answer questions. What is this video? This video is conceptual. Therefore, I am discussing in a descriptive way, in a descriptive manner. For objective, for these type of models, some direct shortcuts are there. We will discuss at the time of objective problems. Yes, we will see an example for this type 3. This is the question. Integral 9 cos x minus sin x by 5 cos x plus 4 sin x. It is exactly in type 3. For this, what is the procedure I said? I said numerator is equal to a into denominator plus some other constant b into d by dx of denominator. Yes. What is numerator here? Listen carefully now. 9 cos x minus sin x is equal to a into denominator. Denominator is 5 cos x plus 4 sin x plus what is there? Plus b into d by dx of denominator. That is its derivative. What is its derivative? 5 into cos x derivative is minus sin plus 4 into sin x derivative is cos x. So I have taken this. Now to find the AB values satisfying this equation. How to find the ABC? Equating cos coefficients on both sides. Here what is the cos coefficient? 5a. There is one more term which is 4b. On the left side cos coefficient is 9. To find two values a and b, we need two equations. Next we will equate sine. A into 4 sine, coefficient is 4a. There is one more sine term here, minus 5b. On the left side it is minus 1. Now solving these two, we can find AB values. So what I do? I will multiply first equation by 5, second equation by 4. Then I will be getting 25a plus 20b is equal to 45. Multiplying this by 4 no, 16a minus 20b equal to minus 4. By adding I can cut these two. So 41a is equal to 45 minus 4, 41. Therefore a is equal to 1. Put a value in this or this. If I put a equal to 1 here, this will be 5. If you write on right side becomes minus. What you get? 4. 4b equal to 4 implies b is also 1. So ab values have come. Therefore now the given integral is integral of, see now, this 9 cos x minus sin x, that means numerator. Numerator can be expressed as this, where a value has come 1. Therefore it is 1 into 5 cos x plus 4 sin x. I am writing numerator. This is numerator which can be written like this. Next plus b. b is also 1 minus 5 sin x plus 4 cos x. This is numerator. This is the denominator which divides both. I will divide separately. 5 cos x plus 4 sin x. Here also 5 cos x plus 4 sin x. dx will be there for entire this. See now, this is equal to integral of 5 cos x plus 4, 5 cos x plus 4. They are same, gets cancelled. We will have 1. What is there? Here nothing will be cut. We have minus 5 sin x. Okay, I will write the integrals for those two separately. Here these two have cancelled. We have 1. Okay, next for this also I am writing separately. Here we will have minus sin x plus 4 cos x divided by 5 cos x plus 4 sin x into dx. Now integration is simple. What is there? 1. Integral 1 is x. Here what is this? What is this one? This one is derivative of denominator. That means its derivative is there in the numerator. That means it is of which standard integrand? Integral f dash x divided by fx, whose integral is log of mod f of x plus c. This is your, see, 5 cos x derivative is 5 cos x derivative minus sin 4 sin x derivative cos x. Exactly that form. Therefore this will be log of f of x. 5 cos x plus 4 sin x, that's all, plus c. This is the answer. Most important model, especially in descriptive exams, final exams. Next we will see type 4 of this rational trigonometric functions. What is type 4? It is for this integral. Integral a cos x plus b sin x plus some constant p whole divided by c cos x plus d sin x plus q into dx. Type 3, it is similar to type 3. In type 3 only these were there. Here these constants also there. For this, what is the procedure? Numerator is equal to some constant a into denominator plus b into d by dx of denominator plus some constant or yes, whatever, you should take a constant. This is the procedure for this type 4. 3 and 4 both are most important in the final exam. These will be asked in the long answer questions. Yes, we will see a problem of type 4. Listen. This is the question. Integral 2 sin x plus 3 cos x plus 4 divided by 3 sin x plus 4 cos x plus 5. What is the procedure? Procedure is numerator is equal to a into denominator plus b into d by dx of denominator. It is a long answer question, lengthy problem, plus some other constant or. Yes, what is numerator? It is 2 sin x plus 3 cos x plus 4 is equal to a into denominator. What is denominator? 3 sin x plus 4 cos x plus 5. I am writing here plus b into d by dx of denominator. What is its derivative? 3 cos x minus 4 sin x. Constant derivative is 0 plus some other constant r. Now to find the three values a, b and r. For that again I will equate the coefficients of cos x on both sides. On the right side cos coefficient is 4a. Here it is 3b. And on the left side cos coefficient is 3. Next equating sin coefficient. Here sin coefficient is 3a and here sin coefficient is minus 4b is what? 2. Isn't it? Now we shall solve these equations. If I solve this, I will multiply first equation by 4, second equation by 3. Then I will get 16a plus 12b equal to 12. And this is 9a minus 12b equal to 6. If I add these two, these will be cut. I have 25a is equal to 18. Implies a is equal to 18 by 25. One value is obtained. Next one, I will write b value in this or this. If I take this one, you can take any one. From this, what is 3b? 3b is 3 minus 4a. Yes, 3 minus 4 into a. This is 1. What is this? 72 by 25. 4 into 18. If I simplify this, 75 minus 72, 3 by 25. This is 3b. Therefore, b is equal to 1 by 25. b also came. We need another value r. For that, equating constants on both sides. Here on the right side, constant is 5a. In the second one, there is no constant, and here r is there. On the left side, the only constant is 4. Therefore, r is equal to 4 minus 5a. 4 minus 5 into a already came. it is 18 by 25. 5 into 18 is 90. 90 by 25. What is this? 100 minus 90, that is 10 by 25. 10 by 25 means it is 2 by 5. So this is R value. So 3 values have come. 18 by 25, 1 by 25 and 2 by 25. Now coming to this, listen carefully, it is lengthy problem, integral of. Here numerator can be written as this. So space is not sufficient, I will erase this. So what was the procedure? Numerator is A value is 18 by 25 into denominator 3 sin x plus 4 cos x plus 5. Then plus b into, what is b? b has come 1 by 25. Yes, 1 by 25 into what we wrote there, derivative d by dx of this, that is 3 cos x minus 4 sin x plus what is r? r is 2 by 5. So this is numerator divided by this. In the procedure we have taken only numerator, expressed that as a into denominator plus b into d by dx of denominator plus r. I have written the numerator. Denominator will be there, no? It divides all. So you divide separately. 4 cos x. It divides this also. 3 sin x plus 4 cos x plus 5. It divides this also. That means 2 divided by 5 into 3 sin x plus 4 cos x plus 5. Yes, into dx. This is our integral. Okay. Yes. Now you please see. What is this? This is equal to, here 18 by 25 is constant. I will write outside. Listen carefully. Now these two are same. They get cancelled. Only one will be there, whose integral is x. Plus we have 1 by 25 here. See carefully. What is this? b into, in the procedure, what was the coefficient? What was the multiple of b? d by dx of denominator. It is exactly denominator of this. 3 sin x, derivative 3 cos x. 4 cos x, 4 into cos x derivative minus sin, 5 derivative 0. Therefore this is exactly which form? Integral f dash x by fx form. So what is that? It is log of mod f of x. That means denominator 3 sin x plus 4 cos x plus 5. Yes. Next one. For this again we have to work out this. I will take, here it is, I will take separately. So I will take only this. I have to find the integral of which one? 1 divided by 3 sin x plus 4 cos x plus 5. What is it? Integration of rational trigonometric functions type 2. For this just now we have seen what is the substitution. Tan x by 2 equal to t. If I apply that, this will be 1 divided by 3 into, there we have seen sin x is 2t by 1 plus t square. 4 into cos x is 1 minus t square by 1 plus t square, plus 5 is there, into dx is what? 2 dt by 1 plus t square. Let us simplify this. Integral of, here 2 into 1, 2 will be there. I will take LCM here. LCM is 1 plus t square. We will have 6t. Here 4 minus 4t square. Next, what about this? If you take LCM, this will be 5 plus 5t square. This LCM 1 by t square, 1 by t square gets cancelled. So this implies, I will write here its continuation. Integral of 2 divided by, see Nana, what is there? 5t square minus 4t square. It is t square. Next, what we have? We have 6t. And also what is the constant? It is 9 into dt. So again, this is of which type? 1 by ax square plus bx plus c type. 2 can be written outside. Integral of. You can factorize this. After finding factorize, you can use partial fractions, or directly you transform this into the form x square minus a square, x square plus a square, etc. But here you please see this. This is simply t plus 3 whole square into dt. Yes. What is this? T plus 3 is linear. For linear, any standard integrand can be applied. I can suppose this is 1 by x square. For 1 by x square, 1 by x square means x power minus 2. What will be its integral? X power n plus 1 by n plus 1 plus c. That is x power minus 1 by minus 1. Nothing but minus 1 by x. Therefore, for this integral is 2 is there. Minus 1 by x, that is t plus 3. I have used this. In place of x, linear is there. I can apply that 1 by x square. But I have to divide this by its derivative. T plus 3 is linear, whose derivative with respect to t is 1 only. No problem. So what is this now? This is minus 2 divided by t. What is t, Nana? T is tan x by 2, no? Therefore, tan x by 2 plus 3. This is the integral of this one. Integral of this one is this. I have to substitute here. So already here what is there? 2 by 5 into integral of this, plus into minus minus. 2 is already there, no? 2 into 2 becomes 4 by 5 into denominator is tan x by 2 plus 3 plus c. This is the answer. Yes. This one is the answer for this question. So, because it is a lengthy problem, space was not sufficient. That's why we did like this. You please note on your notebook, practice this. There will be just 2 problems in any book of this type 4. They are in public examination, descriptive examination, At most important, we can expect this as a long answer question. Okay, thank you.